Hi, my name is Kel Collins. I'm a field application engineer here at Gateworks. Today I'd like to show you how to build a kernel that's custom for your needs. I had someone ask me if how they can get their Realtek Wi-Fi card working with our boards, and the reason why they're having problems is that module isn't included in our pre-built image. So the answer to that is to add it, and in this case we're going to do it by building a kernel with it turned on. For the sake of not making the video too long, I've already downloaded the kernel source. I actually just did a get pull, so it's current. Because we're on an x86 system and we're building this for ARM, we need to cross-compile it. And for that, we have like a cross-compile toolchain. How I do this is I source a file that I created, and it's just a basic text file with all the paths for my compilers and arguments that will be used already there. That way I don't have to type in things individually or source things individually. We'll cat that file. So things that I'm not using, I just comment out. But where did I get this toolchain from? When you build OpenWRT, one of the nice aspects of OpenWRT is that it creates a toolchain for the architecture that you're using. And once it's done building, it leaves that toolchain in this staging directory, staging-dir. And so what I'm doing is I'm just putting that toolchain or that compiler into my path. And what this will do is this will actually it'll just kind of put GCC at the end of this. You can't see it, but that's the blank that'll get filled in. And so these are basically, it's telling, when we build, it'll tell it what compiler to use, and then some arguments for the make file or build system, so it knows what it's doing. Like we're exporting the architecture that we want, the kernel load address, things like that. Our wiki page, track.gateworks.com/wiki/linux/kernel, has all of this spelled out really well, and I'll have it linked in the description. Before we start customizing, we want to have a base that we know will work for our platform. So there's already a def config for IMX6, and so what we're going to do is we're just going to, whoops, that's okay. We're going to go ahead and just make that def config our .config, meaning the config that we're going to use. So there we go, written to .config, and if I cat that file, these are all the settings that are already there. To add this module that we want, we're going to use make menu config. And because we already have that def config set up, basically everything that we need is already here. We're using a like kind of a downstream kernel that has been patched by Gateworks, and this def config, I'm pretty sure, has been modified by our software developers, because they know what should be turned on. So they kind of did a lot of the heavy lifting for us already. If I press the slash key, the one next to shift with the question mark on it, it'll let me search for the configuration parameter I want. In this case, I don't really know what it's called, and so I'm just going to start typing. I know that the chipset is called an RTL8812AU, so I'm going to just try this. RTL88, and let's see what comes up. So here we go. Close enough. The sometimes, so if I press 1, it will take me to enable this option. Sometimes you'll need to turn on other things first, such as depends on, maybe net devices would be a no. And so I would have to go search for net devices, turn that on, and then go back and turn this on. So if I press the number 1, like what's indicated here, it'll take me to the module I want. And then if I press spacebar, the M means it will be built as a module. Star means it will be built static to the kernel. And so I'm going to go ahead and build it static to the kernel. So now I just press escape a few times and save my configuration. Nearly done. So I have a one-line command that I use when I build a tarball, but for the sake of argument for today, I'm going to follow the instructions on the wiki page, which suggests to make a directory called install. I've already done that. And then we're going to give it the targets that we want to build, such as the image, which is, this is actually the kernel, and the U indicates it'll have a U image header on it. I'm sorry, a U-boot header on it. These are the device tree blobs, modules, and headers. And they're going to be put in this install directory. And this can take a while, so I'm going to kind of end the video here, but the next step will be to tar up these targets, and then later what we can do is we can extract that tarball into a root file system that we've created. This is like a greatly I've taken a lot of liberty in summarizing this to get it down to like a reasonable length video. If you have any questions, consult our wiki page, and please feel welcome to contact support@gateworks.com.